Hello, I am Connor Durkin.
And I'm Will Carne.
And welcome to M1 Part B, Newton Gets His Groove On.
This video's got all you need to know for an A star. As with all our videos, if you have any questions, you're welcome to ask down in the comments.
The comment section below.
What did I just say?
I don't know. Comments down there.
Beginning with forces given in newtons, which are vectors. As you will see, the direction is very important.
Très important. Now, you should be clear about the difference between mass and weight. Mass is measured in kilograms and is constant for an object anywhere in the universe.
Weight, however, is the force acting on an object in a gravitational field. As it is force, it's measured in newtons.
You can find the weight by multiplying the mass m by the acceleration due to gravity g, which you will note on Earth to be around 9.8 meters per second.
You know that from our last video.
You should do.
You watched.
Okay then, the other main forces you'll be dealing with are tension, thrust, normal reaction and friction.
The key thing to remember is that for an object to remain stationary, the forces acting on it should be balanced.
So if you have a tortoise sitting on the ground, his weight is the force pulling him towards the centre of the Earth. He isn't being propelled to his death, so there must be an equal and opposite reaction force acting on him. This is called natural or normal reaction force, usually labelled R, going from the turtle up or tortoise upwards.
Yeah, not... Okay.
The ground, sorry.
This force occurs when two objects contact. It is always perpendicular to the plane of contact.
Not an airplane, just a plane. Tension is a similar concept. If you have a weight on the end of a piece of string, the weight will act down in this case, and the tension in the string will act the opposite way to stop the tortoise plummeting to his death. You have a thing for trying to kill tortoises.
The tortoise on screen, he's getting... Yeah.
Oh, he's having a lovely time up there. Not
he's
dying.
hanging at the minute.
Yeah, he's just hanging around. Puns.
Where are we? If the string is light and inextensible, then the force due to the tension is assumed constant throughout.
Essentially, when the examiners say light, they mean it's there to do its main job, ignoring the practicalities of it. So you can assume the string is massless.
Thrust or compression occurs when an object is pushed at one end, like this tortoise, who unfortunately is now propelled to his death.
Oh, I like tortoises. I know. Well, I have a turtle.
We'll see if he makes a comeback later in the video.
Again, if the rod is light, then the thrust is assumed constant and inextensible.
Yep. And finally, friction, which occurs when two surfaces move horizontally, or a component of them do. This can occur in air, but you'll probably use it with surfaces in M1.
That's about it. Now, a few things to note. As a force is a vector, it can be resolved, and almost every question in M1 will make use of that. If it is flat on the ground, then resolve as you usually would to horizontal and vertical components.
But if you have an object on a slope, then it's probably best to resolve horizontal and perpendicular to the slope.
There are more quick methods to this than we care to mention, most simply due to this confusing diagram here. When you resolve the weight, you will get the weight multiplied by sine theta horizontal to the slope and cos theta perpendicular to the slope. This is using Wahey Productions' Triangle of Truth from last time. Now,
questions where the object isn't moving will usually ask you to find unknown forces.
All you do is resolve, and then the forces opposite each other must be equal if it is stationary, so it suddenly gets very easy.
The sum of the forces in any direction is 0.
Well, hey, one thing you may not have learnt is that in equilibrium, if you take the forces in A to scale a diagram... In a to-scale diagram... Sorry, I can't speak.
Sorry, that's my fault. In a to-scale diagram, they will form a closed polygon. This is useless to you mostly, but it may help you when it comes to triangles. A dude called Lamy came up with a theorem for 3 concurrent forces, P, Q, and R, in equilibrium as shown.
He found that P over sine alpha will equal Q over sine... Beta, which equals R over sine gamma.
Connor's losing it. So if you have a triangle of forces, you can save time in the exam by using this.
It is on the syllabus, but it is on the mark scheme as accepted, and it saves a lot of time resolving and fooling around.
Yes, now the last part of the section is friction, as we were mentioning a little bit earlier.
Friction falls in the same category as resistance and tension. It resists motion parallel to the plane of movement.
So, consider another tortoise who needs a name. Let's call him Terry.
Terry the tortoise.
Terry the tortoise is on a hill, on his way home from his brother's funeral. He is sat stationary on the steep hill.
Why is it his brother's... Oh, his brother's funeral was held to the death.
Yes.
Oh.
You see?
Has he got a little black armband on? Please tell me he's got a black armband.
I'm afraid he doesn't. They don't really have arms. This isn't...
They're flippers.
It's a soap. Go.
I'm sorry.
I don't know where I am either.
I forgot.
There is a component of his weight which is pulling him down the hill, but he isn't moving, so the frictional force must be more than or equal to the component of his weight.
He isn't moving, but he is moved by his brother's funeral.
Yes, he is.
Friction is given by mu r, where mu is the coefficient of friction, a ratio differing by surface, so material.
Now the friction will increase to match the applied force. In this case, weight up to a maximum, the limiting friction.
The system is then in limiting equilibrium. There's a little terminology there. Blah, 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 blah.
So, an exam question might say, Terry the tortoise is on a slope. Terry the tortoise is on a slope in limiting equilibrium. The coefficient of friction is 0.5. The angle of the slope is 40 degrees. How heavy does Terry have to be to start sliding down the slope?
And let me assure you, you'll have fun working that one out.
Seriously, go on, try it. I dare you.
One thing to say, mu is the ratio of the limiting friction divided by the resistance force.
So, if the body is on the brink of moving, then the frictional force F equals mu R.
Now moving on to Newton's laws of motion.
Oh, Newton.
Lovely guy.
Can't get rid of him. Can't get rid of him.
He's a bit of a nutter, but
Yeah.
oh well.
Now everyone's heard of Newton and his laws, but no one seems to know which one's which, so here goes.
His first law states that every object remains at rest or moves with constant velocity unless an external force is applied.
So to accelerate the object, you need to apply a force.
Newton's second law furthers that, saying that when an applied force causes an object to accelerate, the acceleration and force are in the same direction and they are proportional by F equals ma, where the mass is the constant to the force's proportionality to acceleration.
This is known as the equation of motion, or Jeffrey to his friends.
Again with Jeffrey. Now using the second law, you can see how you get weight, as g is acceleration due to gravity and m is mass, so the weight is mg, F equals ma. And finally Newton's third law, which famously states that for every action there is an equal and opposite reaction, or as if you, from social point, for every male action there is an equal and unequal and opposite female reaction.
The best way to think of it
Disproportionate.
is Newton came up with the first two laws of motion, and then a third to stop the first two imploding the universe.
Oh, he's so thoughtful, isn't
Right,
he?
okay.
Yay, lovely
Yeah, but
guy.
that gives rise to the hardest questions, where you have two connected particles, usually by strings over a support or a pulley.
So here are some things to assume.
The objects are particles, so you can ignore air
The
resistance.
string is light, so weight of it can be
The
ignored.
string is inextensible, so the two ends of the string have the same speed and
The
acceleration.
pulley is smooth, so the tension is the same throughout the string.
And the pulley is light, so no force is required to turn it.
Ding ding ding. Personally, I think the best way to deal with these questions is to treat them as two separate questions, but linking the two with the tension of the string, which will be the same.
Now, when writing these things, if an object has velocity or acceleration, then write it on the diagram as a separate directed line segment, using a double arrow for acceleration.
Very nice little
It's
double
just a
arrow.
line.
You may use suvat, but only if the acceleration is constant. Remember, if the surface isn't smooth, there will be frictional forces, which in M1 you're told is the maximum, so mu r.
In reality, when moving, the friction decreases a bit, but that's just reality, and we don't care about that in M1.
Reality is useless
Yeah.
to maths.
These skills should take you through any question, but if you have any specific problems, you're welcome to ask down there in the comments or on any of our social networking sites.
But not Google Plus, because no one uses Google Plus.
There's people do actually.
People use Google Plus.
Yeah, we've got about 10 people
Oh.
who plus us.
Oh no, in the circles or something.
Circles. They're in our circles.
Maths. Circles. Same.
Circles.
Moving on to, funny enough, impulse and momentum.
Ooh.
I'm rather impulsive. On to impulse and momentum. Essentially, if you apply a force, its effect depends on the time the force acts.
Now, acceleration is the change in velocity over time, and the force is the mass times acceleration.
So F equals mv minus mu over t.
This can be written as Ft equals mv minus mu, and is defined as the impulse. The unit is Newton seconds.
Newton seconds. Lovely unit there, ladies and gentlemen. The mass multiplied by the velocity gives you the momentum of an object, or to give it its technical term, it's oomph. Yeah, lovely technical term there. The unit of momentum is, again, just making sure you remember Newton seconds. So it's
Yes. And
not
therefore,
newtons per second, just Newton seconds.
using this, you can deduce that the impulse is the change in momentum. Isn't maths cool? No?
Yeah.
Okay.
No.
So, if you want to reduce the force, you increase the time that the object is exposed to it. Hence, crumple zones on cuts.
And that's something a lot of people struggle with in GCSE because it's not absorbing energy, it's just decreasing the time it takes for the force to act.
Yeah.
The principle of conservation of linear momentum, which is much easier than it sounds, states that the total momentum of a system in a particular direction remains constant unless an external force is applied in that direction.
This is probably the most important thing in M1 momentum questions, as the momentum before must equal the momentum after.
And that's where the rest of your M1. You'll probably need all the other info and skills from Newton, Suvat, etc. to do these questions. They're usually a big composite of all the good stuff.
And
And bad
finally,
stuff.
moments, also known as turning forces. If a force F acts at distance d from a point, the moment about the point is given by Fd.
As force is given in newtons and distance in meters, then the moments are given in Newton meters, or Nm.
Now, the way we tend to do it is writing it like this, showing clockwise and anti-clockwise moments about a point.
Now, like with forces, moments can cause an object to be stationary or moving.
If the object is stationary, then the sum of the clockwise moments will equal the sum of the anti-clockwise moments, like in this example.
Look at that. Now, a very important point is that whenever you put the pivot, there is no moment at that point as the distance from the point is 0. So you can ignore any forces that are at that point.
Yes. So if you have two unknowns, put the pivot at one of them, leaving you only one unknown, which is very easy to solve.
Indeed. You could put the pivot somewhere random and then somewhere else and get simultaneous equations, but it's easy just to put the pivot on one of the unknowns.
It is,
to be honest.
and you could put the pivot wherever you like, really, unless they tell you to put it somewhere, in which you kind of have to listen to them.
Yeah, they kind of make the rules in that situation.
Yeah.
Now, if needed, the convention is to take the anti-clockwise moments as positive and clockwise as negative, but they kind of work, it's just maths.
If you're asked to find a distance from the pivot or something like that, then if your answer comes out negative, it's likely that the distance is the other way.
So it's more of displacement than distance.
Yeah.
Something is in equilibrium if all the forces result in 0 and all the moments result in 0 as
The only tricky bit is if you get weird angles to deal with in which you have to resolve and solve.
Resolve and solve, resolve and solve. Now I'm going to end with a trick from us to you that will save you hours of time.
A gift from me to you.
If the situation is stationary and you're looking for a missing force, remember from Newton there must be equal and opposite in equilibrium.
Basically, the sum of all forces pointing up will equal the sum of all forces pointing down.
In it, no, blah.
No, I'm saying.
I will cut you.
I'm not even going to go there,
I'm
though.
gonna cut you.
Don't even say
I'm
that,
gonna
dude.
start.
Get
I'm
at me.
gonna
Get at me.
start.
I'm not even talking.
And with that lovely image, we've got to say,
There we
we
are.
kind of
If you have any
video.
questions, then you can ask in the comments, especially if you're confused about anything or if you've got any tricky exam questions. Happy revising. Good luck in your exams.
Wahey Productions do make other videos other than revision ones. Go check them out when you're not manically revising.
I've been Will Carne.
And I've been Connor Durkin.
This has been a video by Wahey Productive. Thanks for watching.
Bye for now. Bye-bye. Bye-bye. Bye-bye now. Go away. Why are you still
Stop
listening?
being mean.
Why are you still listening?
Huh?
Why are you still listening to us?
Because
away.
I haven't pressed
Not
stop
you.
yet.
Not you, the audience.
Who are we
What
talking
doing?
to?
The audience, they're still listening.
You're looking at me and you're talking to the audience.
You're listening to the audience. What?
Who's the audience? What?
Wow. I've never seen any of the audience.
Maybe there are no audience.
Maybe it's just one dude with that 1 million Google Plus accounts. Just one guy.
Right,
It's me.
right.
It's me. I'm sorry.
Should we go
it's
now?
just me. Yeah, we shall go. Bye.
Bye.